After searching on eBay and Amazon, I bought an overpriced part for 4 times what it's worth, and it didn't fit. So I returned it, reverse engineered it, 3D printed, sanded, and painted it to match the car's interior. Hi, and welcome to the Manic.mech.e. I'm Michelle, a mechanical engineer, fabricator, and car guy. I've been 3D printing functional parts for years now, and I just started applying that knowledge to the NLA problem. In this video, I'll show you what I built, and then I'll walk you through the full process. How I actually go from a broken or discontinued part to something you can print and put in your car. Okay, so let's be real. Drawing a model from scratch in CAD, measuring and designing all the tiny little details turned out to be a lot more work than just buying a new one. The good thing is that I now have a finished product, which I can reprint if anything goes wrong with the one I have. If you've ever been hunting for a part, any part, and came up empty-handed because the OEM stopped making it years ago, or you found a part, but it's 4 times what you're willing to pay for it, or you just found a part on eBay that's exactly as cracked as the one that you have. You know exactly what I'm talking about. That problem exists across every car community. Doesn't matter if you're into JDM, European classics, American muscle, or just trying to keep a daily driver alive past 100,000, 150,000 miles. Parts go away, cars don't. The part I want to show you today is the Sun Visor from my own 2012 Hyundai Accent. Not an exotic, not a collector car, a daily driver. And the visor was destroyed. The plastic internal frame was cracked and the visor was hanging. New OEM, overpriced. Aftermarket, didn't fit. Used, I'd be gambling on something that's the same age and with the same problems. So I made a new one. I printed it in PETG due to it being an internal part that doesn't sit in direct sunlight. And PETG is also dimensionally stable, flexible enough not to crack on impact, and it finishes cleanly. Here's the thing, I didn't print everything. The original visor has a swivel mechanism and a metal frame that were still in perfect condition. There was no reason to reinvent those. So I reverse engineered the plastic body to accept the original hardware. The swivel dropped right in, and the frame seated the same way it did from factory. That's actually a smarter approach for a lot of NLA work. The plastic ages and cracks, the metal hardware usually doesn't. Design around what's still good. Installed, it looks good enough. It fits flush, swivels correctly, and the mirror sits just right. Now, I want to walk you through how this actually works. Because if you're watching this and you've got a car with a part that doesn't exist anymore, I want you to understand what's exactly possible here. No matter what you drive, I want you to see my workflow and tell me what I should be building next. If you've got a part that's been dead for years, that's exactly what I want to know about. Drop it in the comments, show me a forum thread. That's genuinely how I'll decide what to model next. A lot of people assume this process is find a part, scan it, hit print. It's not, especially with NLA. The original is usually cracked, warped, or missing entirely. You're not copying a good part. You're reverse engineering the old one. That's a different problem, and it's actually the more interesting one. This is where most of the actual work is. For the Accent visor, I had the original in hand, damaged, but intact enough to measure. That's the best case scenario. But I want to be honest about what reverse engineering actually means here. I'm not scanning this, I'm measuring it with calipers, understanding how it functions, and rebuilding it from scratch in CAD. The scan gives you geometry. The engineering gives you a part that actually works. These are 4 key things I'm figuring out in the initial phase. Number 1, interface geometry. Where does it attach? Where does it pivot? What hardware does it retain? For the visor, that meant the swivel pocket and the frame channels had to be exactly right before anything else mattered. Number 2, what failed and why? The original cracked at the swivel area because the internal plastic frame became brittle over time and one day just decided to give. That's a design fix, not just a copy. Number 3, what to keep from the original. The swivel mechanism and the metal frame were fine. Only the plastic body needed replacing. Designing around the existing hardware kept costs down and made the fit precise. Number 4, load paths and flex points. Where does the part take stress? A sun visor flexes every time you move it. Layer orientation in the print needs to be accounted for that. If there's no original to measure from, which happens, I would work from forum photos, teardown videos, and measurements. It's slower, but still doable. The community usually has a lot more dimensional data floating around than people realize. Once I know what the part needs to do, I model it from scratch. Here's what I'm thinking as I build. Constrained features. The dimensions that are non-negotiable because they have to mate with existing hardware or structure. Everything else can be adjusted. Design for the print, not just the part. Injection molded parts can run very thin walls because the process supports it. FDM needs more material for equivalent stiffness. I'm also thinking about where I want layer lines relative to the load direction. Tolerance compensation. FDM parts come off the bed slightly different from nominal. Tight fit features like the swivel socket need explicit compensation built into the model. Designing out supports. Overhangs cost time and surface quality. A small geometry change can eliminate a support entirely. I'll iterate 2 to 3 times, or 10, or 15. Let's just say it takes some iteration and paying attention to a lot of little details before I'm satisfied. The initial prints find the problems. Material is a real decision, not an afterthought. For the Accent visor, PETG is the right call. It's an interior part and it's not in direct sunlight. PETG prints clean and won't brittle over time, or melt in the summer sun the way ABS can. For parts that do see direct sun, anything near a window or on the dash, I would move to ASA. It's UV stable, heat tolerant to around 95 degrees Celsius, and doesn't get brittle with age. One caveat, it needs an enclosed printer, but for exterior or sun exposed parts, it's not optional. Color matching is its own challenge. If I can't get close enough with filament color, I'll print in a base color, sand it, and finish with Automotive spray paint. That handles UV exposure and gets you a lot closer on color. First print off the bed goes straight to a fit check. Not looking for perfection, just what needs to change. Usually it's a socket that's a fraction too tight or a surface that needs a couple millimeters removed. Then I'll decide if it's worth going back to CAD to reprint the affected area and then check again. Or if I can just get away with some type of modification like cutting off a couple millimeters to help it fit. The good thing about getting your printer settings just right is that most parts ship as printed after a light inspection and cleanup. For painted surfaces, I sanded to 80 grit to knock down the layer lines and help the glue and paint stick. For this visor, the hardware dropped in, the frame seated. I CA'd glued it, clamped it, then sanded, painted, sanded. Yeah, it was a long process. I'll be totally honest. I also used a little Automotive body filler for some parts that were giving me a hard time. I then painted, glued on the mirrors, and popped them right into the car. That's the finish line. If there's a part you've been hunting for, tell me what it is and I'll make a video of that next. Right now, I'm working on a portfolio of parts from community requests. If this helps you, or if you know someone who's been hunting for a part, share this video with them. That's generally how I'll find what to make next. Subscribe if you want to follow the builds. There's more NLA work coming. And I document all the engineering and fabrication work on this channel. And if automotive parts aren't the only thing you're here for, stick around. I've been working on something completely different on the engineering side. It's a remote controlled lawnmower. That video is coming next. So if this is your kind of thing, like and subscribe, and I'll see you in the next video. Testing, testing. Next. Uy, cambia eso que me siento como empanadilla.
We come to you live from the White House. Aliens have just landed.
Okay, great, but less intense. Perfect. Bondo! Seriously, guys, if you want to sponsor me, go ahead.